Hi, this is Jay from paulpolito.com, and welcome to the next installment in our Paul Polito screencast series. 104.5, Manage File Permissions and Ownership, Part 1. In this screencast, you will get overall information about permissions and ownership of files in a Linux system. In addition, you will get to know the rights flags SUID, SGID, and StickyBit. File permissions on Linux. Files and directories are always owned by a user. The owner determines the file's owner class. Distinct permissions apply to the owner. Files and directories are also assigned to a group, which defines the file's group class. Distinct permissions apply to members of the file's group. Users who are not the owner nor a member of the group comprise a file's class called Others. Distinct permissions apply to others. There are three specific permissions on Linux systems that apply to each class. The read permission, which grants the ability to read a file. The write permission, which grants the ability to modify a file. When set for a directory, this permission grants the ability to modify files in the directory. The execute permission, which grants the ability to execute a file. In this example, the file numbers.txt belongs to user Paul, and he has permission to read, write, and execute this file, rwx. The file also belongs to the group Paul. Members of this group have permission to read the file, r-. Others do not have any rights for this file, --. The first character of this line determines the file type. The following file types are defined on a Linux system. The file type definition is followed by the file permission construct. The first three characters describe the owner permissions of the file, the next three the group permissions, and the last three the permissions of others. The character R means read permission, W means write permission, and X means execute permission. It is also possible to give this permission in an octal notation. Take a look at the following list. In case of a numeric notation, the numbers of each category are summed together. A file permission of rwx r would be given to the system as the number 740. The 7 is the sum of 4 for read permission, plus 2 for write permission, plus 1 for execute permission. The 4 comes from the group's write permission, and the 0 means no permission at all for others. For clarification, read permission means that the contents of a file are readable. Write permissions mean that one may change the contents of this file. Execute permissions means that if the file is a program, the user has permission to execute it. For directories, read permissions mean that one may see the content of a directory. Write permissions mean that creating or deleting files is permitted, and execute permissions grant the ability to traverse its tree in order to access files or subdirectories. Set user ID, set group ID, and StickyBit. For security reasons, 3 additional permission flags were added to the existing 3. These flags are set user ID with a value of 4, set group ID with a value of 2, and StickyBit with a value of 1. The set user ID option is used in conjunction with executable files, and it tells Linux to run the program with the permissions of whoever owns the file, rather than with the permissions of the user who runs the program. If the SUID is set, an S instead of an X will appear in the user file permission. The Set Group ID option is similar to the SUID option. The difference is that it sets the group of the running program to the group of the file. It's indicated by an S in the group execute bit position in the permission string. When the SGID bit is set on a directory, new files or subdirectories created in the original directory will inherit the group ownership of the directory, rather than be based on the user's current default group. The use of the sticky bit is on directories. When the sticky bit is set, only the item's owner, the directory's owner, or the superuser can rename or delete files. Without the sticky bit set, any user with write and execute permissions for a directory can rename or delete files in this directory. Typically, the sticky bit is set on the /temp directory to prevent ordinary users from deleting or moving the files of other users. SUID, SGID, and sticky bits are normally set with the command chmod by setting the high order octal to 4 for set UID, 2 for set GID, or 1 for sticky bit. Here's a list of all file permissions in a Linux system. Summary. Files and directories are always owned by a user. The owner determines the file's owner class. Distinct permissions apply to the owner. Files and directories are also assigned to a group, which defines the file's group class. Distinct permissions apply to members of the file's group. Users who are not the owner nor a member of the group comprise a file's class called Others. Distinct permissions apply to others. There are 3 specific permissions on Linux systems that apply to each class. The read permission, which grants the ability to read a file. The write permission, which grants the ability to modify a file. When set for a directory, this permission grants the ability to modify entries in the directory. The execute permission, which grants the ability to execute a file. Permissions can be granted by using the chmod command in 2 ways, in octal form or in characters form. For security reasons, the normal file permissions were extended by adding the write flags SUID, SGID, and sticky bit. Study points. LPI will expect solid knowledge of file permissions. Make sure to be familiar with the procedure of how to grant file permissions by using characters and numbers, and also by using the chmod command. Memorize the different file types mentioned earlier in this screencast. Study the terms SUID, SGID, and sticky bit well. Be aware of the fact that the Manage File Permissions and Ownership chapter has a weight of 3 in the LPI exam. Therefore, you can expect questions regarding this topic, so be well prepared. This is Jay from Paulpolito.com, and thank you for watching this Paulpolito screencast. Until next time.